Okay. Excuse me. Frog in my throat. All right. Here we are. We're going to talk about parallel and perpendicular lines. So our goal today is we want to be able to write equations of lines that contain a given point and are parallel or perpendicular to a given line. And we want to be able to write an equation that is parallel or perpendicular to the x or y axis and determine whether the slope is 0 or undefined. Actually, we're going to put most of our work into the top one, more so than the second one, but we'll discuss that one in a second. Anyways, let's look at this. Okay, the vocabulary here. Parallel lines. Lines with the same slope but different y-intercepts. So notice here the number in front of the x is the same, but the numbers after the x are different. Perpendicular lines. Lines with slopes that are opposite reciprocals. So 2/3. Notice here how I have 2/3. And then -3/2. Opposite reciprocals. Another thing that you can... Okay, weirdly, my iPad decided to change something on me, but another thing you can make note of here is that if you multiply the two slopes, 2/3 times -3/2, you get an answer of -1. When you multiply two slopes and get an answer of -1, that's perpendicular. All right, so let's look at an example. Write an equation in slope-intercept form that passes through 4 -2, I should say through 4 -2, and is parallel to the graph of y equals 1/2 x minus 7. All right, so when we're doing this, folks, what we're trying to do here is we're trying to say, okay, look, first off, we're going to write an equation of a line. We want to use the point that they're giving you, and we want to use the slope from the other one, but we got to decide, is it going to stay the same or is it going to change? Parallel means I want the same. So I'm going to use that slope, 1/2, and the point, 4 -2, and then I'm going to go through point-slope form. So y minus equals parentheses x minus, notice all my blanks, y with y, x with x, slope in the middle. So then y minus a -2 becomes y plus 2. Then I can distribute, because I want it in slope-intercept form. So this is point-slope. Now I got to go to slope-intercept. So I need to distribute. So 1/2 times x is 1/2 x. 1/2 times 4 is 2. Move the other 2 over to the other side. The plus 2 becomes a minus. -2 minus 2 is -4. So coincidentally it came out back to what was in parentheses, but that's just weird coincidence. Let's start getting used to writing this as f of x, because I noticed some of y'all are forgetting about this, but do not forget, y and f of x are the same thing. So you need to make sure, because more likely on end of course, a star, you're going to see it as f of x. Alright, so here's another one. Write an equation in slope-intercept form for the line that passes through 6 -2 and is perpendicular to the graph of y equals -3x plus 4. So in this one, I want to be perpendicular. Now, that means I need to change the sign and take the reciprocal. The reciprocal of 3/1 is 1/3. And since it was negative, it should be positive. So then I'm going through all my same steps. Y minus, do the point slope form, -2 minus -2, do the 6, make it plus 2. Then I can distribute. We're going to distribute in a second. I'm letting it play it slowly so you can see what's going on here. So 1/3 times x was 1/3 x, 1/3 times 6 was 2, minus 2 again. Believe it or not, I'm making these numbers up off the top of my head, and this is just weirdly that they coming out with a y-intercept of -4. That's just coincidence. I don't know what the heck was going on with me then. But anyways, there you go. So the answer is f of x is equal to 1/3 x minus 4. So notice here, we're going through the same steps, stuff that we should be doing from the last test, and we're building on it. That's what we're always constantly trying to do. We're trying to build on what you've done, but if you're not doing it, it's not going to be able to be done. So what I need y'all to make sure you're doing is keep working on it. It will get easier and better if you keep working on it. All right, so how about what happens if it's in standard form? Okay, now notice here, this is not in y-intercept form, so I don't see the slope immediately. So I want to write an equation that's parallel, but to do that, I still have to find the slope. Now remember, if it's in standard form, it's negative a over b. In other words, you're going to say negative 3 over negative 1, which is just 3. So I'm going to use that slope. By the way, that's the symbol. There you see those two little lines under the m, or by the m. That's the symbol for parallel. So my parallel slope would be 3, and I'm going to use the point 2, 1. So I'm going to say here y minus 1, 3, and then 2. Then I can distribute, which is what I'm doing. 3 times x is 3x, 3 times 2 is 6. Add 1, and then I will end up with a minus 5. Of course, change that to f of x. So it'd be f of x equals 3x minus 5. But there you go. And we are done with that example, but not done with the whole thing. Okay, the next one says write an equation in slope-intercept form for the line that passes through 14, 6 and is perpendicular to the graph of 7x minus 2y equals 3. Again, before you do anything else, you have to find the slope. Find the slope of this line, then you can worry about the perpendicular. Now, slope of this line is, again, negative a over b, which means negative 7 over negative 2, which is positive 7 over 2. Then, flip it and change the sign. That's perpendicular. Flip it and change the sign. So, negative 2 over 7. I'm going to use that negative 2 over 7 with a point 14.6 and go to point slope form. Y with y, x with x, slope in the middle. And you're going well. Okay, now distribute negative 2 sevenths x. Negative 2 sevenths times 14 would be positive 4. Now keep in mind, some of this you can just do with a calculator. Like something like the 2 sevenths times 14 you can do with a calculator. Okay, so I'm recopying it over here on top. I'm going to add 6 to both sides and end up with 10. 4 plus 6 is 10. And then you get y equals negative 2 over 7x plus 10. Then change it to f of x. F of x is equal to negative 2 over 7x plus 10. Yes, there we go. So that's kind of it right there. Now, that is how you get the equations. The next thing is they're going to ask you is, how do you see, can you tell if it's parallel or perpendicular just by looking? So keep in mind, if I want to look, we're going to decide is a group of lines parallel, perpendicular, or neither. Parallel, again, they have the same slope. Perpendicular, opposite reciprocals, the product is negative 1. For example, if I had these two examples here, 3x plus 2, negative 1/3 x plus 5, the slopes are 3 and negative 1/3. If you multiply them, equals negative 1. So thus, those two lines are perpendicular. It's more fun when you say perpendicular. We're only going to do one example with this one, so let's look at that example. Ooh, look at it, goes fast. Ah! All right, I'll start right there. Okay, so determine if y equals negative 2x plus 1, comma, x minus 2y equals negative 4, comma, and y equals 3 are parallel, perpendicular, or neither. And I'm giving you the symbols for parallel, perpendicular, or neither. So let's look at these. If you look at A, the first one, I'll say that's A, y minus 2x, y equals negative 2x plus 1. The slope there is negative 2. That one's simple. The second one, x minus 2y equals negative 4. If you do the whole negative a over b, then that would tell you the slope is positive 1/2. And then see y is equal to 3. If it's y equals just a number, the slope is 0. If it was x equals a number, the slope is undefined. Okay, so on this one, we can do this. If I look at these, I can see that A and B, lines A and B are perpendicular. They're opposite reciprocals. Lines A and C are neither, because negative 2 and 0 have nothing to do with each other. And lines B and C are neither. because, again, nothing to do with each other. All right. I probably was going to stop there, but I do want to add one more thing, so be prepared for that. I'm going to pause real quick, and then I'll give it to you. Okay, for the x-axis, let's talk about being parallel or perpendicular, because I've seen this pretty much every star, saying like this line is which one is parallel to the x-axis, or which one is perpendicular to the x-axis, or parallel to the y-axis, okay, anything like that. Keep in mind, on the x-axis, you have the x-axis is a horizontal line. Okay, and the y-axis is a vertical line. So if I want a number, something parallel, I would want y equals some number, any number, just a number. Perpendicular would be x equals a number, just a number. And then for the y-axis, that would be the opposite. X equals a number would be parallel. Y equals some number would be perpendicular. Keep in mind that when it's y equals a number, the slope is 0. And when it's x equals a number, the slope is undefined. We really don't need, say, examples for that, but there you go. Just wanted to make sure you had that. Might be something good to start learning and memorizing and getting down, but maybe even for a note card for a test. Anyways, that's it for today. We are done. Thank you very much for your time.